Mastering time series analysis. Missing values in time series data are a ticking time bomb to data integrity and operational excellence. Which strategies and techniques do you employ to handle and manage missing values in time series data, ensuring data integrity and maintaining operational excellence in time series analysis? Handling and managing missing values in time series data is a critical aspect of maintaining data integrity and ensuring operational excellence in time series analysis. There are several strategies and techniques that can be employed to handle missing values, and the choice of strategy depends on the nature of the data, the type of missingness, and the goals of the analysis. 1. Listwise deletion. One of the simplest strategies is listwise deletion, which involves removing any rows or observations that contain missing values. This approach is straightforward but can be problematic if the missing values are not missing completely at random, MCAR, as it can lead to biased estimates and inaccurate conclusions. Furthermore, listwise deletion can result in a significant loss of data, particularly if the missing values are scattered throughout the dataset. 2. Mean/median imputation. Another strategy is to impute the missing values with the mean or median of the respective feature. This approach is simple and easy to implement but can be problematic if the missing values are not missing at random, MAR. Mean/median imputation can also introduce additional variability and bias, particularly if the missing values are not representative of the overall distribution. 3. Regression imputation. Regression imputation involves using a regression model to predict the missing values based on the observed values. This approach can be effective if the relationship between the variables is strong and the missing values are large. However, regression imputation can be computationally intensive and may not perform well if the data is high-dimensional or contains complex relationships. 4. K-nearest neighbors, KNN, imputation. KNN imputation involves finding the K most similar observations to the one with missing values and imputing the missing values based on the values of these neighbors. This approach can be effective if the data is highly correlated and the missing values are large. However, KNN imputation can be computationally intensive and may not perform well if the data is high-dimensional. 5. Principal component analysis, PCA, imputation. PCA imputation involves using PCA to reduce the dimensionality of the data and then imputing the missing values based on the reduced features. This approach can be effective if the data is high-dimensional and the missing values are large. However, PCA imputation can be sensitive to the choice of components and may not perform well if the data contains complex relationships. 6. Expectation maximization, EM, imputation. EM imputation involves using an iterative approach to impute the missing values based on the observed values and the underlying distribution. This approach can be effective if the data is incomplete and the missing values are large. However, EM imputation can be computationally intensive and may not perform well if the data is high-dimensional. 7. Multiple imputation. Multiple imputation involves creating multiple versions of the data, each with the missing values imputed using a different strategy. This approach can be effective if the data is incomplete and the missing values are large. However, multiple imputation can be computationally intensive and may not perform well if the data is high-dimensional. 8. Data augmentation. Data augmentation involves artificially increasing the size of the dataset by creating new observations based on the observed values. This approach can be effective if the data is small and the missing values are large. However, data augmentation can be computationally intensive and may not perform well if the data is high-dimensional. 9. Matrix factorization. Matrix factorization involves decomposing the data matrix into low-rank matrices and then imputing the missing values based on the factorized matrices. This approach can be effective if the data is high-dimensional and the missing values are large. However, matrix factorization can be computationally intensive and may not perform well if the data contains complex relationships. 10. Deep learning-based imputation. Deep learning-based imputation involves using deep neural networks to impute the missing values. This approach can be effective if the data is high-dimensional and the missing values are large. However, deep learning-based imputation can be computationally intensive and may not perform well if the data contains complex relationships. In addition to these strategies, it is essential to maintain operational excellence in time series analysis by monitoring data quality and detecting anomalies, Implementing robust data preprocessing and feature engineering techniques. Using robust statistical and machine learning models that can handle missing values. Implementing data validation and verification procedures. Continuously evaluating and refining the data quality and analysis pipelines. Maintaining transparency and reproducibility throughout the analysis. Documenting and communicating the results and methods clearly and concisely. By employing these strategies and techniques, analysts can ensure that missing values are handled and managed effectively, maintaining data integrity and operational excellence in time series analysis.